Good afternoon, and thank you for tuning in for the latest Easergy webinar. I'm Dan Loosemore, the Managing Director here at Easergy, and I'll be chairing this afternoon's exciting case study-based webinar with leading energy management and automation specialist Schneider Electric. Before introducing the themes and the contributors for this afternoon's session in more detail, just a couple of housekeeping items to run through. Firstly, the presentation is available to download as a PDF file and also as an MP3 audio file for easy access. Of course, the webinar will, as ever, be available on demand on easergy.com, so please do share with colleagues and industry professionals who you feel would also benefit from today's key learnings. As always, we like Easergy webinars to be as interactive as possible. If you have any questions, please submit them as we go along, and I will tackle as many as possible in the allocated time at the end of the presentation. In this webinar, we'll be treated to a deeper dive look at how distribution service operators are benefiting from greater automation across the network, with growing demand, stricter environmental controls, pressure on operational costs. There really is a time for distribution networks to transition to ensure they're delivering greater reliability and also ensuring efficiency. Of course, implementing these capital projects successfully requires strong partnerships. And today we look at the business case for greater adoption of automation tools, focusing on recent projects with EDP in Portugal and Western Power Distribution. We're joined by Schneider panelists, including Pekko Grudowski, who's the launch manager. Pekko is responsible for the worldwide launch of the T300 solution. With a master's in electrical engineering, his professional path has always been somewhat related to automation and utilities. He is currently dedicated to helping utilities address their smart grid challenges. We're also joined by John Langley-Davis, the Product Marketing Manager at Schneider Electric. John is responsible for product development and launches at Schneider. He's worked with Western Power Distribution since the outset of the T300 product development and will share his experience today of the considerations, implementation and benefits in the context of a rapidly changing grid architecture. Finally, Philip Gill is the Electric Utilities Account Manager at Schneider, and he's responsible for business development for the Portuguese utilities. So he'll be bringing us today insight on the recent project with EDP, and akin to Pekko has an MA in electrical engineering, so a great level of expertise joining us for this webinar. And I'll hand over to the experts to kick this webinar off first this afternoon. Thank you all for joining us. Really looking forward to it.
Hello, good afternoon. It's Pekko Grudowski speaking. First of all, I would like to make an introduction regarding your utility segment. What are the challenges that we are able to answer, and particularly the domain of application, that is the feeder automation, before to switch off to the two different use cases in Portugal and UK. Related to your segment, utilities is made of four major domains composing the entire value chain, that is the generation, transmission, distribution, and retail. However, utilities have one or multiple roles across these domains, depending on the regulation in each geography. And based upon specific local situation, their model can be either regulated or deregulated. In addition, nowadays, the power ecosystem is affected with three trends. Decarbonization, which means the increase of distributed energy resources on the grid. Digitization, more and more data across the grid. And decentralization, the consumers are developing power generation capabilities. Concerning this utility distribution domain, our Schneider Electric portfolio is based on four major domains of application. The first one is a substation, which means a set of transmission and distribution substation systems acting as a nervous system of the grid. The second one is the control room, a set of software applications supporting grid operations and asset management. The microgrid, different forms of interconnected energy systems like highland, building, etc. And the feeders, related to distribution network control and monitoring for the medium voltage, low voltage part of the network, spread over large geographies with an objective to ensure a reliable grid, as well voltage management and asset management. And during this webinar, we will focus on the feeder domains of applications. In these days, utility, Europe, are facing increasing pressure to improve the reliability and efficiency of the electric grid, while at the same time enhancing power quality. Must also answer on growing energy demand and a higher ratio of distributed energy resources, such as renewable energy sources, distributed storage, and electrical vehicle sharing stations. All of them connected to the medium voltage or low voltage distribution levels. In addition, you, utility, are looking to extend the lifetime of aging infrastructure and to reduce the installation, operation, and maintenance expenditure. Let's focus on the first major challenge. You became increasingly sensitive to quality of service, as the electricity is the primary source of energy for residential homes, buildings, and industry worldwide. The quality of electricity supply is measured and published in indexes, and usually you're using reliability indicators that are too well known: the System Average Interruption Duration Index, SAID, which calculates the average outage duration, and the System Average Interruption Frequency Index, SAIF, which calculates the average number of interruptions. Those indications serve to track and benchmark your reliability performance in order to improve it. On the second hand, one of the main responsibilities around the world is to maintain voltage fluctuation within limits as contractually agreed and requested in network codes. The voltage control has traditionally been performed by transformers using on a load type changes and capacitor banks that inject reactive power into the grid and located at the high voltage, medium voltage substation level. The distribution system operator fixes a set point and prepares a scenario and range based on forecasted load and production curves, for example. As a result of the massive integration of distribution energy resources into the medium voltage, low voltage grid, the voltage management today presents a major challenge. Cases may differ depending on whether the distribution system operator coverage area is urban or rural, and on the type of density of connected distribution energy resources. We have to manage situations where voltage may be rising on one part of the grid while decreasing on another, or to deal with the unexpected behavior of distributed energy resources due to the weather conditions. On the other side, the LV part of the distribution networks are often heavily unbalanced between transformers, between the low voltage feeders within a transformer, and between the three phases of one given transformer. With the massive injection of distribution energy resources, for example, photovoltaic panels, these imbalances are amplified. These imbalances also cause joules losses in wires and transformers due to the higher current level on the more heavily loaded part of the network, and also to current flow in the neutral wires that were usually not designed for such situation. The third scope of challenges are linked to the assets optimizations. You are facing increased pressure to reduce their capital expenditure and operational expenditure. With a huge portfolio of valuable assets, you are looking for any means to optimize the use of existing assets, to extend their lifetime and reduce the cost of operating and managing them. This pressure is even more pronounced considering the changes needed to support a higher rate of distribution energy resources. Easergy T300, the feeder remote terminal unit, exists today to help meet these challenges. The medium voltage, low voltage substation is becoming the cornerstone of distribution automation to help improve those challenges. A modern feeder automation remote terminal unit like Easergy T300 can maximize the benefits of smart assets by hosting some local automation and advanced fault detection, or in the case of conventional assets, a dedicated function to accurately monitor the quality of delivered energy. And by communicating with the control centers or with other substations on the grid, using standard protocols can be also used for centralized or decentralized network reconfiguration. At the same time, to ensure the robust, reliable remote control and monitoring of the underground and also on the overhead network, the feeder automation RTU like Easergy T300 meets a high level of electromagnetic compatibility immunity. That was the first part regarding the introduction of the feeder automation domain and the challenges. Then we can switch to the poll question session.
Pekko, thanks ever so much for that overview. I think a really good introduction to some of the challenges in terms of what DSOs are now looking at in this digital age. It actually brings us to our first poll question for this afternoon's webinar. We mentioned that we like the NJRT webinars to be as interactive as possible. This first poll is related to some of the challenges that Pekko was just discussing. Audience, you'll see it on your screen now. If you could please vote for us, and then we can look at the results of this first poll. The question, as you can see, is what is your biggest challenge in the electrical distribution grid? And it runs through a good number of those challenges that Pekko's just illuminated for us, looking at integration, management of outages and those reliability challenges, and even with the digitization of the grid, things like cybersecurity. So if you could please place your vote now, that would be fantastic. We'll give you 20 seconds or so to do that. Okay, thank you very much all. And before we dive into the use cases, there's still some votes coming in, so I'll give you a second. Okay, thank you very much. We're going to bring these results up onto your screens now. And what you can see is, I think, actually, Pekko, it perfectly illuminates your opening there, because we're seeing an increasing number of utilities and DSOs really looking at trying to optimize that network efficiency. But I think your solution helps, and we'll hopefully see that in a minute when we look at the case studies. Also, increasingly with the digitization of the grid, cybersecurity has come up as a big issue, as well as reliability. I think outages with the cost implications that they have obviously impact the service being delivered. So when we're looking at these case studies coming up now, I think it's also important to reflect back on what that means in terms of reliability for the utilities and DSOs. What does your solution play out there? And to perhaps answer some of these questions, that brings us to the next portion of the presentation, where we're going to take a deeper dive into the case study with EDP and what it means for the utilities based on that project. So I'll hand back across to you guys at Schneider to tell us a little bit more about the DSO case study there.
Philip Gilles speaking. Good afternoon. Thanks for the opportunity to share with you the project that we are deploying on our client's network involving the new Easergy T300. On the coming minutes, I will share some insights about the challenges that our client faces and a glimpse of our history on the local market, followed by a deep dive on the solution design that is under deployment. EDP Distribuição has the concession of the distribution network in Portugal mainland. EDP activities are regulated and they have two main challenges that each year they have to cope. Guarantee a proper quality of service according at least with the standards defined by the regulator. Second, improve the operational efficiency. Adding to this, on the past years, they have been dedicating attention on the reduction of the energy losses, explicitly the non-technical losses. Now, new trends associated with distributed energy resources and electrical vehicles are arising, and with those, new challenges to the DSO. In order to be prepared to successfully manage those, EDP is doing a strong push on innovation, and they have decided to invest on the network operation digitalization, namely on a smart metering infrastructure and on the increase of medium voltage feeder automation and low voltage sensors. All this will help EDP to have on real time a more precise picture of the network and enable them to operate it more efficiently. However, this profusion of technology and communication brings a new challenge related with the cybersecurity of the entire infrastructure. As expected, all these challenges impact the choices taken by EDP concerning the equipment, the automation equipment deployed on the network. I believe that automation is much more than only equipment. It is also the ability to understand the local market characteristics and design customized solutions. This is what we have been doing in Portugal on the past 15 years. In 2002, we entered the market with the Easergy T200, firstly with the solution for the underground network, and later with the overhead solution. We have been able to keep a successful track record, being one of the leading suppliers, and we believe that with the new Easergy T300, we are well prepared to honor the past and continue building fruitful relationships with our DSO clients. In 2014, the market requirements changed and new functionalities like directional fault detection start to be mandatory. Last year, with Easergy T300, we were able to comply with the new market standards and get the first project. On the next slides, I'm going to share some project characteristics, the reasons why we succeed, and the added value we believe we bring to our clients. EDP innovative project related with the smart grid started almost 10 years ago with a high level of international awareness and recognition. One key feature that distinguished this project from others was the decision to merge inside one equipment, the Distribution Transformer Controller, or DTC, two realities, the smart metering and the network operation, acting the DTC as a data concentrator and a feeder RTU. This was a very generous vision that aimed to make the best use of all the data available at the MVLV substation level to create distributed intelligence. In 2014, after several pilots and years of experimentation, the InnovGrid concept became EDP new standard for medium voltage network automation. Here we have an overview of EDP automation solution for the substations that has a distributed architecture, as you can infer from the schematic. This solution is the same for existing substations or for new ones. The core of the solution is the DTC. This is the only equipment of the grid concept that is installed on all substations. On automated substations, two additional bricks have to be added. First big brick, the switch controller module, one per switch, that will be the interface between the DTC and the medium voltage switch, performing several functionalities like current and voltage measurement, fault detection, switch status and control. The second brick, an interruptible power supply cabinet, providing 230 volts AC to the DTC and 48 volts DC for the automation modules. Based on Easergy T300 modules, we design a solution 100% compliant with our client requirements. On the top of the slide, you see two pictures of the solution developed, installed, and on service on existing substations. The SC115 module allows us to fulfill all the requirements defined for the switch interface. In addition, the SC150 provides more functionalities that EDP may use in the future, like power measurement and power quality. The HU250 is the glue that allows our solution to communicate with the DTC exactly as expected and demanded by our client. Lastly, with the PS100 as the main piece, we built a specific power supply cabinet complying with demanding electrical and environmental characteristics. I highlight three factors that contribute for the success of this project. First, the modularity and compactness of Easergy T300 that allowed us to design a distributed solution in a very effective way and scalable according to the client needs. Two, the communication and programming capabilities of the HU250 that were key to link our solution with the DTC and address some specific operational requirements imposed by EDP. Three, the people involved on the project from both sides, from our Automation Center of Excellence and from EDP, that were able to understand the needs and from a great equipment design a performing solution. We believe that Easergy T300 brings numerous benefits to the utilities. I will refer just for that EDP distribution may take advantage of. One, increase of the market competitiveness with more than one qualified supplier. Two, Easergy T300 modularity may allow different architectures to address different needs. As an example, all modules can be packed inside one cabinet for retrofit applications, or all modules dispersed and placed inside the medium voltage switchboard for new substations. Three, seamless low voltage monitoring inside the substation with the T300. And four, Easergy T300 cybersecurity compliance aligned with the DSO policies. With this, I end my presentation regarding the Portuguese DSO use case. Thanks. I will pass for the poll questions.
Thanks ever so much for Felipe. It's always great to have the use cases on the webinars, and it leads nicely into our second poll this afternoon. You mentioned a lot of key drivers for the improvements on the distribution networks and what utilities and DSOs are looking at in terms of their key needs when they're looking at implementing this greater level of automation. You'll see now a poll question going live for our next survey being sent, which asks a question around what drives a DSO to improve the distribution network performance. You have 6 answers to choose from, so we'll give you 20 to 30 seconds to select your survey response. Thank you. And again, when you're answering, it ties back into some of the issues that Felipe was just talking about there in terms of the greater pressure on regulation and the fault reduction that came up as a big challenge from poll number 1, as well as emerging issues with the emergence of new technology around standardization as well. So what we're looking for here is the key driver that would move DSOs towards these implementations. You've got just 5 seconds left. And you'll be able to see the results on your screen now. And what we're seeing from this poll is actually 45% of our responses are looking at the cost in terms of ongoing maintenance and what it means in terms of that reduction in operational expenditure. I think there's understanding that there's a capital expense towards these new automation products, but actually if it can be made defendable and there's a business case in terms of reducing that total cost of ownership, it makes it a lot more attractive. And I think that's something that your use case certainly brought out, Felipe. But there's also a lot of consideration around regulation and the penalties that are being brought in terms of reliability and emissions and that sort of regulation there. So it's something to bear in mind as we move towards our second case study this afternoon, looking at the work that's been done on the distribution network with Western Power Distribution. So I'll hand back across to our Schneider experts for this portion of the presentation. Thank you.
Thank you very much, Dan. And thanks to Pecco and Felipe for their presentations. My name's John Langley Davis, and I'm a product marketing manager for Schneider in the UK. So it's all the way from Lisbon to Leeds, where I'm at our medium voltage centre of excellence. And today I wanted to share with you our experience of enabling and assisting a customer to roll out T300 onto a large distribution network. We've seen from the presentations this afternoon how T300 has been designed specifically for the challenges of the rapidly changing networks we can see in front of us. And that can be done at a variety of different scales. But I really wanted to spend a little time explaining the process of how we worked with Western Power Distribution to enable them to roll it out on a large scale. Okay, so Western Power Distribution have 4 of the licensed areas in the UK. It's a very diverse network. You've got everything from large cities like Birmingham, the second biggest city in the UK, through to very sparsely populated rural areas in Cornwall and South Wales. And what I'm going to hope to explain today is how Western Power deploy a very kind of optimized solution for quite a variety of different applications. I think Western Power did a very good job of understanding what all those potential applications were. They were already purchasing a Schneider feeder RTU before T300. They achieved it by really following a similar process in terms of the way they use their plant centers to load configurations onto the unit. Schneider agree with them which firmware versions will be on the products that are shipped. They then deploy the RTU from the plant center, so it's tested before it goes to site, and they really use those plant centers as a method of controlling the process. We've been working with UK DNOs and DSOs for over 30 years deploying feeder RTUs in the UK market. Now we support Easergy T300 in the UK from our Energy Application Centre in Chippenham. WPD have been able to roll out the Easergy T300 with very little risk because they've built the product on the standard configurations for each of their radio systems, and also they've standardized on a 2-switch variety of the product or a 4-switch variety of the product to make as few references as possible in the ordering, as few possible scenarios for their operational staff that are installing the unit, and therefore creating as few possible situations where challenges can be encountered in the field. Now, the standardization story doesn't really end there with T300. We've been working with Western Power for many years on standardizing, on limiting the number of configurations of Ringmaster RN2C ring main unit, and now the new Ringmaster RN2D ring main unit, which you can see in front of you on the screen there. This has really allowed us to consider in quite a lot of detail the potential roadmap for how and when and why we implement different functions with them on the smart ring main unit. In some cases, it's actually led to simplification of the process. For example, when we were using previous feeder RTUs, we would be fitting core balance CTs onto ring main units to give us a sensitive earth fault detection, whereas T300 has such fine level data reading and management that actually we can deploy sensitive earth fault detection without using core balance CTs on T300. And actually there's functionality within T300 that we've still yet to deploy with Western Power, and there's plenty of opportunity in the future for deploying the types of technology that solve some of the problems that Pexo was talking about earlier, like directional fault patterns indication and LV monitoring, and really starting to use the Easergy T300 as the kind of the automation hub of the secondary distribution substation. One thing I wanted to go through as well was the process that we actually used with Western Power to make sure that the product was deployed properly. So it was really a lot of time spent analysing possible applications and configurations of the unit. There was a significant amount of lab testing that went on with those configurations, checking that they worked with the SCADA system that the DSO uses. And then we went into the detailed process of deploying pilot units in the field and real substations. We actually, fortunately, managed to find one ring where there had been a problem on the ring, and it did reconfigure the network as planned, and which is sometimes quite hard to find when rolling out these kind of trials. And then also there was a really big kind of support task in terms of training the staff, making sure that the processes between ourselves and Western Power were optimized to make the product easy to order, easy to ship, easy to deploy in the plant centers, as I mentioned earlier, and then to run into a kind of a stable process for ordering large volumes of automation product. The benefit here is that in order for a DSO to really tackle this challenge, having a system in place whereby you can easily deploy the automation is in some respects as important as having the right automation technology on the network. And then the last box there is really about a partnership approach, working between ourselves with Western Power and Schneider to look at the future requirements of the network and make sure that the product is configured and optimized, and the roadmaps are matched up for deployment. But so if there's any questions after, then please feel free to ask. But I think I'll hand you over to Dan for the final poll question of this afternoon session.
Yeah, thanks ever so much, John. It's always, as you said, a key part of implementation isn't just defining the business case, but agreeing on what that roadmap needs to look like and putting in a long-term project management approach, which leads nicely into this final poll, looking at how our audience as DSOs manage deployment of the secondary switchgear or automation solutions, and whether that is a full smart grid approach or whether it's typically done through a pilot scheme in the first instance to test the product and to test how it's going to implement on the system. So again, you'll see this question on your screens now. We'll give you 30 seconds or so to respond. As John highlighted, I think one of the key things when looking at any project like this in terms of digitization on legacy grids is to have a collaborative project management approach and really think about what that rollout looks like and the time frame for it. So this would be an interesting one in terms of your responses here and what the typical approach is currently. You've got just over 20 seconds. Very interesting. We're looking at a fairly even split for those of you that haven't responded yet. You've got 10 seconds to do so. Okay, thank you very much. You'll be able to see the results on your screen now. Thank you all for taking part. I think, John, this ties nicely into some of the points you were making in terms of the survey results. I think it very much is a case of collaboration and partnerships being the order of the day, because you can see just in terms of the responses we've had here, there is a real mix of people who are looking at partial deployments, full-scale smart grid approaches, and even looking at sort of more legacy retrofitting of SCADA projects. And I think this links back to why partnerships with companies like Schneider are so important, because actually there will be an element of understanding and unique parts to every single project you undertake, which I think was borne out as well through the case studies that we've looked at so far this afternoon. And maybe we can come back to that in the Q&A in terms of how you deal with different utility sets of requirements. So thank you very much for that. We'll come on to the final part of the presentation now.
Thank you, Dan. I would like also to thank Philippe and John for their very clear and understandable and detailed presentation regarding the two different DSO use cases with the different approaches, one for the retrofit, one for the new substations, as well on the process, how we can collaborate in order to deliver the right solution for your feeder automation application. And now I would like to summarize with the global benefits that also can be linked, associated with Easergy T300 as part of our EcoStruxure grid architecture. EcoStruxure grid is our IoT architecture that is dedicated to the grid, and T300 is part of this architecture, and it is about to manage the grid itself and make the grid more reliable, secure, and to make the grid operations more efficient. Go back to the first benefit that is associated to the outage time reduction. In the public distribution application, the traditional medium voltage, low voltage substation are equipped with the ring-main unit with switch fuse solution or circuit breakers for medium voltage, low voltage transformer protection, and manually operated load break switches for cable switching. When a fault occurs, a crew should be sent into the field in order to identify the location of the fault, possibly helped by checking the position of the fault passage indicator in different medium voltage, low voltage substations, and if such devices are installed on concerned feeder. And this approach is time consuming and very costly and may lead to long outages. The presence of distributed energy resources makes the detection of faults even more sophisticated and may require a fault passage indication function to be directional type 1. When a distribution network is operated as one open loop, strategic electrical node, including the normal open point, need to be equipped with optimized remote control and monitoring capabilities. including motorized switches. This feeder automation solution based on Easergy T300 can clear electrical faults. For example, as Felipe previously and John mentioned, directional overcurrent detection, but also broken conductor detection, neutral cutout detection, closest to where they happened, rather than exclusively clearing them at the primary substation, requesting then that this feeder automation system be connected to the outage management center to communicate that a fault has occurred. The fleecer, or the fault location, installation, and supply restoration, centrally and remotely manage all Easergy T300 units located on the medium voltage feeders, with the objective of isolating the fault section and restoring the power to a maximal number of the grids. The fleecer can be centralized or even decentralized application. Otherwise, the grid operator may miss the event and many grid users would be left without power. On the second scope of benefits related to the integration of distributed energy resources, thanks to the Easergy T300 high accuracy capabilities, the DSOs can deploy high performance sensors like low power voltage transformers, LPVTs, to monitor the voltage along MV feeders and to calculate all associated data needed for fault direction, advanced automation, such as active and reactive power, the power factor, and reactive energy. The monitoring and analysis of the reactive energy that flows on MV feeders and for each of the phases in the secondary medium voltage and low voltage substation would allow to locate the areas of the grid with more reactive energy and to easily work on a solution to minimizing them. In addition, the Easergy T300 with the low voltage monitoring capabilities is able also to identify imbalances in real time, on average or every 10 minutes, and it will contribute to solve the low voltage phase balancing and to reduce the technical losses. Deploying the smart capabilities on the feeder, ability to manage assets remotely, sophisticated, meaningful data are shared among mobile field crews, remote operators, and maintenance centers thanks to the smart communication standards embedded in the Easergy T300. More accurate information about assets behavior enables you, utilities, not only to reduce the number of costly field maintenance visits, but also to ensure efficient and proactive equipment operating. Taking into account that underground and overhead electrical network impose strong environmental constraints, and in order to ensure the robust, reliable, remote control and monitoring of the medium voltage, low voltage network, the Easergy T300 meets a high level of electromagnetic compatibility immunity that traditional industrial controllers do not reach. I will mention another part of the benefits that is related to the cybersecurity. The logging and monitoring are the area where principles such as unique users, predefined users, and IT secure protocol are directly deployed in a device like Easergy T300. Easergy T300 applies standardized cybersecurity technique and technologies in order to protect critical infrastructure like medium voltage, low voltage substation from cyber threats. However, the implementation of cybersecurity mainly depends on the utilities organization, which is a key to perform and control correctly their critical infrastructure, and we, as a Schneider Electric, is willing to contribute in defining your cybersecurity environment. Today, Easergy T300 is ready to answer on all those challenges that you are facing and you will facing in the future. As the heart of any electrical power distribution system, the medium voltage, low voltage substation with the feeder automation in the smart ring main units with advanced sensor capabilities has for a name to keep grid power flowing, balanced, and routed appropriately. This substation, located most closely to the vast majority of grid users, are becoming the cornerstone of the electricity grid evolution. Transitioning medium voltage, low voltage substation assets to host these new smart capabilities like feeder automation is becoming the neurologic aspect of any smart grid deployment. I would like to thank you again for your attention and this possibility to share with you our feeder automation application and the new Easergy T300 offer. And I would like also to thank you again to Felipe and to John for their wonderful presentation.
Thanks ever so much, Pekko. And yeah, thank you to John and to Felipe as well. And it's fantastic to have a webinar with 2 use cases attached to it. And I think that's been reflected in the level of engagement we've had in this webinar this afternoon. We've got a lot of questions coming in. So I'll go straight to them if I can. And Felipe, perhaps to yourself to begin with, you mentioned low voltage monitoring. Could you perhaps explain a little bit more about the benefits of LV monitoring in your use cases?
Hi. Briefly, I would say the medium voltage network operation visibility and control is quite good today and continues improving. Now we are deploying smart metering infrastructures, and so the information at the client's delivery point will be fairly good. I believe the LV monitoring at the substation level, complementing the other information, will allow the implementation of algorithms or disperse intelligence, and will contribute to improve the network efficiency at the LV side. One example, and Pekko shared that during his presentation, is the imbalance of the loads and the detection of non-technical losses.
Thank you very much. Yeah, I think that ties back into what we saw from the survey result earlier on this afternoon in terms of efficiency and that need to prevent outages being key for utilities and DSOs at the moment. Pekko, you talked a little bit about the solution and how it can help with some of those challenges. What would you say the main differences are between this kind of RTU from others looking at medium or low voltage automation?
Yes, thank you, Dan, for this question. I will relate to one of the slides of Felipe when he summarized the benefits of the T300 offer. The first one is the flexibility. That means he mentioned that this offer can be at the same time very compact, low power consuming, that can be installed in a small cabinet to retrofit the already existing substation. It can be with a Schneider switchgear or a third-party switchgear. This is the flexibility, and at the same time can be distributed thanks to the modularity and the easiness of installation based on the Ethernet communication between the modules inside the low voltage cabinet of the ring main unit. That means distributed and compact architecture, but also the same offer are related to underground and overhead network applications. This is regarding the flexibility. I will add as well the cybersecurity natively features based on the cybersecurity standards, and as well not only focused on the medium voltage, but as well a module that is dedicated for the low voltage monitoring part. And when we are mentioning a medium voltage part, the 3 major features that previously was mentioned by Felipe and by John in the respective use cases. In a very small footprint, we are able to provide the control of the switch, full passage indicator, and power monitoring on the medium voltage and as well on the low voltage side of the network.
Thank you, Pekka. And perhaps you touched in your answer there looking at cybersecurity compliance. Obviously, this is a key issue for a lot of the DSOs at the moment. What security standard is being referenced as acceptable, and how are you guys at Schneider as the key partner in a lot of these projects dealing with this concern?
Yeah, I will take this question as well. For the product perspective, that means from the cybersecurity, but dedicated for the ID, intelligent electronic devices on the field, we are relating to one worldwide standard based on IEC 62351. And inside there is a different chapters for the role-based access control for protocols, and the utilities are not dealing with the specific specification for the cybersecurity. We are related to this worldwide standard that is managed by IEC community 62351.
Thank you very much. And John, it was something you touched on in your presentation. If we can come back to yourself for a second. We saw in terms of when utilities are looking to adopt new RMUs or for types of RMUs already commissioned and installed on the network without automation. What are the latest technologies that can be used to help automate them or retrofit greater automation onto those existing infrastructure?
Thanks, Dan. I think it's interesting when we look at this question in the context of a device like T300. I think if we'd have discussed this question 10 years ago, we would have been talking about merely being able to open and close switches on the MV network, and that is relatively straightforward in terms of retrofit automation. And at Schneider, we've managed a number of projects in the UK with other DNOs like Northern Power Grid, for example, where we've retrofitted automation onto Schneider switchgear, third-party switchgear as well. But when we get into some of the, for example, the directional fault passage indication has come up today as a pretty big topic and a pretty big requirement going forward. That requires a voltage reference to be taken from the equipment, which I think, when you look at legacy switchgears that could be 20, could be 30 years old, it adds an extra level of complexity, I think, to that retrofit discussion. And the real challenge is the same as it's always been, I think, in that where do you find the happy medium between putting in new switchgear and automation, and where do you find the kind of cost-benefit analysis in retrofitting particular locations? I've certainly seen it done quite successfully by some DNOs, DSOs in the past, but for sure, when I look at it in the context of T300 and the more advanced devices, because they need more data, it would be great to do it, but it would be more challenging to do it and to incorporate some of the latest functions.
Absolutely, yeah, and I think it's probably a pragmatic and again a collaborative approach needed when looking at how to deal with both new implementations and some of that legacy 20 to 30-year-old infrastructure that you just talked about. To give our audience a bit of a view on it, what percentage of the network at rest and power that you worked on is currently managed with the automated solution that you presented?
I don't know a truly accurate figure. I think it's probably somewhere in the region of about 30% or something like that. So I think the customers definitely need the business case needs to be strong enough for different substations, because it's not just about installing and purchasing the automation device. It's also about making sure that the comms network is sufficiently robust and actually in existence in the area where the substation is. So I think I think most DNOs and DSOs are still under about halfway with automating the units, but I don't think that's necessarily because everybody wants to automate every single unit. I think on a very large and very diverse network like the ones we have in the UK, the amount of investment that would be required to automate every unit, I think that would be a pretty tough business case for people to put together.
Yeah, thank you. That makes a lot of sense. Pekko, actually linked to John's response there, if we can come back to you for a second. Are we starting to see now in general more requirements for standardized communication being implemented in products like the T300, or are we still predominantly working on the sort of remote SCADA telecontrol protocols? What's the sort of move towards standardized comms that you're seeing in these project requirements?
Well, we can see in terms of the standardized protocols, in the most of the cases, there are two types of, can be based of IC60870-5, that means 101 and 104. Most of the cases 104 because we are implementing IP technologies of communication as well on the DNP3. Not yet 61 and 50, but in some area of the world, there is the request for ready for and no implementation on the field. And regarding the communication technologies, in terms of the media of communication, are in most of the cases based on the IP. It can be private radio or can be a public telecom, but in the most of the cases, IP technology of communications due to the amount of data that need to be shared.
Sure, thank you. And we've got a question here specific to the T300 itself in terms of how they adjust to changes in the feeder configuration. Is this a case of reprogramming them, or how do they adjust to those feeder configuration changes? Could you talk about that a little for us?
Yes, for sure. First of all, thanks to the modularity of the T300, when we are adding an additional, switch on feeder that need to be automized, we just need to plug an additional switch controller module, and remotely, because in the most of the cases the Easergy T300 are linked in a remotely IP network, can be send the additional configuration for that is taking into account these additional modules, and will be restarted remotely to operate with the new configuration related to the network.
Perfect, thank you. That certainly makes it a lot easier, and actually it's a growing concern that we're seeing on the site. If I can ask just one final question, Pekko. Obviously a lot of the concern around these new installations is that the interoperability and the retrofitting. Is this a device that can be installed on any secondary stretch gear? Maybe you could give the audience a bit of insight there.
Yes, for sure. I tried to mention that can be retrofit all the existing medium voltage, low voltage substation, can be underground or overhead. If we need to motorize, that means the switchgear need to be motorized in order to remotely control them. But in terms of the interface with the motor and with the status of the switchgear, this Easergy T300 is compatible with any type of switchgear for any type of medium voltage, low voltage substation. And I would like just to mention that it's also compatible with different type of neutral systems related to the fault indication function.
Thank you very much. Yeah, I think that's going to be an increasing issue. So it's good to see that already being considered. I think that brings us to the end this afternoon. It's jam-packed, that Q&A session. So thank you to Pekko, Felipe, John. This afternoon, it's great to have all three of you join us and be able to take those questions. It really is much appreciated. And thank you to the Engerati audience for your interaction this afternoon. We've seen fantastic uptake on those survey questions and questions for our panel at the end there. So thank you to our panelists, and thank you for listening. Thank you all very, very much.